Hello, welcome to Einstein's Mechanics. In today's episode, we are going to look at nodal analysis without voltage source. So, we are still doing the circuit analysis, how to find current and voltages in circuit. And now we are on the nodal analysis. So, we've tackled the branch analysis, the mesh analysis. So now let's talk about the nodal analysis. And we have our circuit. First, we must understand what a node is, and we know that a node is where two or more branches meet. So in this circuit, we are going to have node at this point because the branches meet at this point, and we are going to have another node at this point, and we have another node at this point. So we have three nodes within this circuit. So the node analysis is going to help us to determine the voltage at this node and to determine the voltage at this node and what is the voltage happening at this node. So this may be volt 1, volt 2, and volt 3. That will help us to determine current flowing through this branch, current through this branch, current through this branch. So once we get the node analysis, we can also get the current from the voltage we have calculated. It's quite simple. So let's get to work. So this is a circuit, and we are to make analysis of voltage and current. Now, within this circuit, our analysis is going to be without a voltage source. So here we can see that there is no voltage source. This is what we mean by voltage source, where we have a battery resistors connected. Are you okay? And this is a resistor, this is a voltage source. But looking at this circuit, the larger one, there is no voltage source. This arrow is a current source. The arrow, this is a current source, and this is also a current source. There's an analysis of nodal analysis where we involve a voltage, but in this episode, we are only taking without voltage source. So let's get to work. So now this is a current given in the circuit, so I will call it I1 as this current I1. This is also another current given in the circuit. I'll also call it capital I2. I'm just assigning current to the branches. And if this current is moving, this I1 is moving, as it gets to this node, it is going to split. Part is coming this way as the capital I2. We have it already. And there's going to be a flow here and another flow here. So I'll call this small I2. This is just assigning current. You can choose any symbol to represent it. I will call this I1. Are we okay? So as this current I2 is also flowing through this branch, as it gets to the junction, it is going to come down here because two currents are coming. The capital I2 is also coming, and by Kirchhoff's current law, if two currents are entering here, the third branch should leave. So I will also call this as I3, small letter I3. Please pay attention to the nodal analysis because it's very simple and many people get it confused. So now I have my currents assigned to the various branches. Now I'll also assign my resistors. I'll call this as resistor 1. I'll call this as my resistor 2, and I'll call this as my resistor 3. Are we okay? So in order to do the nodal analysis without the voltage source, these are the steps to follow very strictly. So 1, always select a node as the reference node. In the circuit given, you are going to have a number of nodes. As here we have 1, we have 2, and we have 3 as the third node. Select one of the node as the reference node, what we also mean as ground. the ground node. We are going to assume that at that node there is no voltage or zero voltage is happening over there. So between the three of the nodes, I'll prefer to ground this part or use it as the reference node. So this node, I'll ground it as the reference node. So I'll choose this part as the reference. That's the first step in the nodal analysis. You ground one of the nodes, which is also called the reference node. And the second point is you assign voltage. Assign voltages to the remaining nodes. So now within the circuit there are three nodes. I'm grounding one of them, so remaining two, that's this one and this one. And the next step is you assign voltage to the remaining non-reference nodes. So I'm going to assign voltage that at this first part, this voltage at the node is V1, and at the second node the voltage is at V2. Are we good? So if there are 6 nodes, you are going to ground one of them and assign voltage V1 up to V5 to the remaining non-reference nodes. So now we have our second step. The third step is you apply KCL to each, pay attention, to each of the non-reference node. So when I talk about the non-reference node, it is the nodes without being grounded, those nodes that we did not ground it. Remember, if there are a number of nodes, we are only going to ground one and assign voltages to the rest. And we apply KCL, Kirchhoff's current law, to the non-reference nodes. That is very simple. So looking at this circuit, let me apply the KCL to the nodes. So for the first node, so we know that this is the first node, this is the second node. So on the first node, let me write it as node 1, such that the analysis will be very simple. So node 1, this is the KCL. We know that the current I1 entering into the node I1 is entering. So I1 is equal to the current capital I2 is leaving. We can see that I2 is leaving plus I1 is also leaving plus the small I2 is also leaving. So this is the KCL at node 1. I'll call this equation 1. Let's look at the node 2. What is the KCL over there at this particular node? What is happening? And we can see that the current entering, that is capital I2 is entering plus small I2 is entering equal to the I3 leaving as the second equation. Are we okay? So now we can also start the other approach. What do we do from here? Now, after we've applied the KCL, what we have to do is we have to express the current in terms of node voltage. So we are going to express the various currents or the currents in voltages. Thus, we know that current is equal to the voltage on the resistance. So now we have the various currents. Capital I1, let's look at the current. We have capital I1, capital I2, and we have small I1, small I2, and small I3. Pay attention here. In the node analysis without the voltage source, we are likely to be given the values for this capital currents. So let's say current I1, the current source will be say 5 amperes, and this will be say 2 amperes. We are always given. So what we are going to look for is this small letter currents. So in this expression of the current in voltage, we will try to express the small letters in terms of what? Voltages. So what do I mean? Now, if I am going to express the I1 in terms of voltage, that is going to be voltage on resistance. And current I1, this current I1, let's check the diagram, is passing through this resistor 1. This is the current I1. And what is the voltage happening? Look at the voltage. The voltage is, this current is moving from a voltage V1 to a voltage grounded. At the ground, the voltage is equal to 0. Do you understand? So current I1, the small letter I1, is happening between the voltage V1 and the voltage at the reference node, which is V0. So that is going to give us from V1 minus up to V0, or the 0 voltage, over what resistance? R1. This is the same as V1 minus 0 will be like V1 on R1. Let's do that for I2. I2, let's check the current I2. I2 is also moving through the resistor 2. And let's check the voltage. It is moving from node 1, which is V1, up to the node 2, which is what? V2. So its voltage is going to be from V1 minus V2 and passing through what resistance? R2. Do we get that? So this is for the first I1 and this is for the second I2. Now the I3, this is just an explanation before we go through some examples. The I3, we can see that current I3 is moving through resistor 3, and checking the voltage, it is moving from voltage V2 and the next voltage to it is the ground voltage 0. So that one is also going to be from voltage V2 minus the ground voltage 0 on the resistance R3, which is the same as V2 on R3 in that. So now that we have the current expressed in voltages, we can then re-establish the equation by bringing in these equations into equation 1 and equation 2. Then we can do our solution. Now let's look at, if we bring in this voltage current, how are we going to establish the equation? Now from equation 1, so let's look at from equation 1. Let's write. So equation 1 is the I1, capital I1, and as I said, capital currents, the current source are going to be given. So we don't need to express it in voltage again. So I1 is known. I1 will be equal to, I2 will be also given a value. So I2 plus small letter I1, and small letter I1 is expressed in V1 on R1, plus we have small letter I2, which is also expressed in V1 minus V2 all on R2. So this is now our equation 3. Okay, so from equation 2, we are also going to express it again. Now from equation 2, I2 is given. We know the value for I2, plus small letter I2, which will be V1 minus V2 on R2, should be equal to small I3, which is V2 on R3. And this will be equation 4. After getting equation 3 and equation 4, you will see that you have a perfect equation in terms of V1 and V2. And here we are going to apply simultaneous equation, and we can solve equation 3 and 4 to get the value for V1 and V2, so that we will know the nodal voltage at node 1, and whatever we get for V2 will be the nodal voltage at V2. And imagine if we have V1 and V2, we can calculate the small current I1 because the resistance will be given. We know V1. If we know V1, V2, we can calculate for small I2 because we know R2. and V1, V2. So all the currents and the voltages can be known. Are we okay? So let's try this example very quickly. So example 1, it says calculate the node voltage in the circuit. So we have this circuit given, our resistors are given, and the current source. You can see that there's no voltage source in this circuit. We only have our current source, which is 5 amperes up and 10 amperes over here. So here we are to use the nodal analysis to calculate the node voltages at every node. So first we have to identify the number of nodes we have. So looking at this circuit, you can redraw the circuit again, but because I'm solving, I'm going to use the same circuit. Now we have node 1 here, we have node 2, and we have node 3. So 3 nodes. And what we have to do first is, now we select one of the nodes as the reference node. If the diagram is drawn, it is easy to determine which to use as the reference node. So I would prefer to ground this part as the reference node. So this will be grounded, and this voltage will be, so it is 0, the ground. Are we okay? So that's the first step. Now I'll try to assign the current to the circuit. I will assign the current. The 5 amperes current is coming down here. So it is going to split here and it is going to split over there. So I'll call this part as my I2. That's just what I want to call it. And I'll call this part as my I3. Do we see that? Now, if I2 also gets to this junction, it is going to split. And it is splitting, part is coming this way. Don't say it is going, some is going this way, because already this 10 is coming from that part. Are we okay? So what we are going to have is a downward current, which is going to be, let me call it, I have I2, I3, and I4. Because at this node, we can see that the distribution is what completed. We have 2 currents leaving and 2 currents entering. Are you okay? So now I have my current assigned, and I have to also assign voltages to the node. So I will call this first node as my V1, and here I'll call it as my V2. That's the voltage 2. Now I'll apply the KCL at the node. So at node 1, what is the KCL over there? So node 1, what do we see? We can see that the current 5 amperes is entering. So the 5 amperes is entering, and that is equal to the current I2 leaving plus I3 also leaving. Are you okay? So now I have this established. Now I have to express this current in terms of voltages. Remember, we are talking about voltage, so I have to express the current in terms of voltages. So meaning I2 is going to be, and we know that our current is equal to voltage on what? The resistance. So I2, where is current I2? This is I2 passing through the 4 ohm resistor. So that is going to be voltage on the resistance. And looking at the voltage, it is moving from voltage V1 to voltage V2. So meaning that is going to be V1 minus V2. And what is the resistance? That will be 4 ohms. So we are done. We also have I3 to be equal to, checking for I3, it is also passing through this 2 ohm resistor, and the voltage is between the V1 and the ground. Do we see that? So meaning that is going to be V1 minus the ground voltage, which is always 0, over the resistance, which is 2. And this is the same as V1 on 2. as that. The analysis is very simple. Do we see that? Okay, so now we can bring them back into the node equation. So that is going to give us 5 is equal to, we have our V1 minus, so V1 minus V2 on 4 plus we have V1 on 2. So this equation now is mathematics. If you want to simplify this equation, you can simplify it and you are going to get 3V1 minus V2 should be equal to 20. Yes, that's what you get, because the LCM you can multiply through by what? 4, and you just make the equation so simple. So this is my equation 1 from node 1. Remember, the number of nodes is going to give you the number of equations. So we are done with node 1. So let me go to node 2. What is the current analysis at node 2? So at the node 2, you can see that the current entering is, we have the 10 is entering, plus I2 is also entering, which should be equal to the 5 amperes is leaving, plus I4 is also leaving. Do we see that? Now we have expressed I2 already from node 1 in terms of voltages. Let's try to express I4 also in terms of voltages. In terms of voltage, I4 will be equal to, I4 is passing through the 6 ohm resistor, and that is going to be from V2 to the ground, and the ground is 0 and the resistance is 6, and that is the same as V2 on 6. So bringing it back into the equation, we are going to get 10 plus I2, which is now, we have the expression for I2 down here, which is also now V1 minus V2 on 4 should be equal to 5 plus I4, which is V2 on 6. Now, this is just mathematics equation. If you simplify this equation, you are going to get your negative 3V1 plus 5V2 should be equal to 60. Equation 2 from node 2. Are we okay? So we have equation 2. So if you have 3 nodes, you are going to have 3 equations, 4 nodes, 4 equations. After grounding one of them, the remaining number of nodes will be the number of equations you are going to have. So now solving equation 1 and equation 2 using simultaneous equation. Simultaneously, what we have is, our V1 is going to give us a voltage of 13.333 volts, and our V2 is also going to be 20 volts. This is what we have after solving the equation. The solution is mathematics. You can use your calculator. So now the question is, calculate the volt or the node volt in the circuit, and the node volt at node 1 will be 13.333 volts, and at node 2 that is going to be 20 volts. You can proceed to find the current through this. Now let's try and see. At I1, I don't have I1, so I2. So I2, check the expression. I2 is equal to V1, which is 13.333 minus V2, 20 on 4. Your I2 is going to give you negative 1.67 amperes. So this is the current. If the question asks you to further calculate for the current, and your I3, the expression is V1 on 2, and V1, that is 13.33 on 2, your I3 is going to give you 6.67 amperes. And lastly, you can also find your I4. I4 is also from the expression, we have V2 on 6. So I4 is V2 on 6. V2 is 20 on 6, and that is going to be 3.33 amperes. So this is the way to analyze the node voltage. Are you okay? I hope this example helps. In the next episode, we are going to solve another example to see how best we can do the nodal analysis. This is without a voltage source. Kindly subscribe to the channel, like, and check out for the next episode for the next example. Thank you.